Okay, guys. So there's a few ways that I want you guys to actually think about potentially using dispatch and weave. Okay, because it's elusive. Like by me asking you to use them, it's probably put a bit of a spanner in the works. Like some of you can't actually work out what to do. Like what did we use dispatch and weave for last semester?
Finger joint.
Right.
Boolean values.
Huh?
Boolean values is dispatch.
Yeah, we use Boolean values to dispatch to create finger joints, yeah? But a lot of designs don't have finger joints. And unless you're modeling like the parapets of Government House, you probably don't need dispatch and weave, right? And that's just me giving a hint to one of the students here of what they could actually use. So just consider that you can use dispatch and weave for things that wouldn't technically be considered computational design, such as this Victorian fence could just have been a series of lines that we've dispatched, and then we've cut one of those dispatch elements, like the B element, let's say, and therefore we've then created this pattern, yeah? Or we could think of Japanese house plan, traditional. I'm just having a guess here.
Oh, fuck, that's bright.
Or let's go. So don't necessarily have to think of patterns as two-dimensional. You can also think of them as in one-dimensional. You can also think of them as two-dimensional. So we could fatten up. So you could see these columns, this one, and this one, is starting to have, like, there's this relationship happening there in regards to maybe it's thicker, maybe it's got something that comes out the top, maybe it's got a brace on it. So you don't necessarily need to use these to create finger joints, okay? So what does weave do? What does it do? Branko, I'm not expecting you to answer. Oh, okay. What does it do? It overlaps. Okay, can you explain that a little bit more eloquently? Explain it to someone who doesn't know what it does.
It's an overlapping array.
Okay, do you want me to have a go?
Yeah, sure.
Weave takes two lists and intertwines those two lists using a pattern. No, you didn't. Okay, it overlaps. It overlaps. Okay, so one really good technique of using weave, one that probably all of you potentially could use in your designs, and one that I use to make stairs, is making stairs. Okay, stairs can use the weave component, and so there's many ways to skin a cat, and there's many ways to do stairs. But if you've got a surface, then you can create stairs off that. Okay. So what I'm going to do is I'm going to take a surface. I'm going to bring it into Grasshopper. Now, yes.
Are you recording it?
Yes. Do you want me to double check? Yeah, I'm recording it. By the way, that was Corky. Just remember, Corky is being a smartass. Okay. Okay. So, some of you mentioned that you're having a hard time getting geometry out from Rhino into Grasshopper. I think a lot of what was taught last semester, you guys were basically expected to do everything in Grasshopper, right? So just remember that anything that's drawn in Rhino can be brought into Grasshopper as an input, and that can be done using parameters, okay? So if we've got a surface in Grasshopper, in Rhino, we can bring that into Grasshopper by using this surface component, right-clicking it, select set one surface, and that will then bring that into Grasshopper, okay? That doesn't, this requires you to know exactly what you're bringing in though. So if you've got a BREP, you need to use the BREP component. If you've got a surface, you've got to use the surface component. If you know you're just referencing any geometry, then the geometry component's a bit of a cheat because it doesn't matter what it is, it'll pick, if it's a point, it'll pick it, if it's a line, it'll pick it, it'll grab anything. And if you want to make it even more vague, the data component will grab whatever you want. It'll grab numbers, it'll grab geometry, doesn't matter, okay? Cool? Either way, we've got a surface, and we're going to do something to a surface that I don't believe we actually did last semester, and that's divide it. So divide surface effectively works similarly to dividing curves. Do you remember how we divided curves? But it does it in the u and v direction. So u being the surface's x relative to the surface, and v being its y relative to the surface. And in this case, I'm going to create some sliders. Is everyone familiar with the shortcuts to write sliders, such as if I want the number 1 to 20, I can type 1 is less than 20, hit enter, and I've now got a slider that goes from 1 to 20. Everyone good with that one? Yep, okay, so that's going to plug into U, and we're going to copy that and plug it into V. And the outcome of this is we want the U count to be the number of stairs there will be, and the V count is going to just be 1, okay? Because from this, we produce branches with 2 points. So we're dividing by 1, therefore we get 2 points at the start and the end. And how many branches do you think we're going to get? If I've plugged in 10, I've divided that by 10 segments. So how many branches will I have? Oh, you've gone the wrong way. 11. Okay? Because there's 10 segments, so there are 11 divisions, yeah? Okay, so does everyone remember what branches are in Grasshopper? Okay, Vincent remembers, that means everyone remembers, okay? No.
That's the opposite.
Do you remember what branches are? They're lists of lists, okay? And anything in a branch is only going to think of that self within its branch, okay? So if I create a polyline right now from this list of points, what that's going to do is draw a line just between the points in those branches. So this particular branch and this branch are separate, and therefore the polyline only goes between those. If I flatten this into like a flat list, what happens to the polyline? It connects itself up, okay? So just remember, branches organize our data in a way that we want to accentuate. And so by maintaining the branches, we draw lines between those points. Super quick way of doing this, okay? The only reason I'm doing it this way is because it saves me having to do it the long way, right? Because we've only got 20 minutes left. Okay, so if I've got these lines now, if I were to look at this in elevation or section, all I really need is for each of these lines to create a connection like so. Yeah? And therefore I create stairs. Yep. So what I can do, well, just a quick question. What am I doing if I'm taking a point, such as this point, and I do this, what am I doing to it? And in what direction am I moving it? In the Z direction? Okay, so let's take our lines and transform them by moving them in the Z direction. Therefore, we get lines that then move up by 1, yeah? So what have we got? Let's just flatten this polyline list as well. We've got a list with 10 lines, and we've got a list with another 10 lines. Now, if I were to try and combine these two lists together, we don't want to combine them on top of each other, right? We don't want to go consecutively from 0 to 10 and then from 11 to 21, yeah? If I were to merge these, Well, look, let's just do it. Instead of merging them, we want to weave them, yeah? Because we want to intertwine them. We want 0 to then correspond with 0, and then from that 0 to go to the 1, and then 1 in this B, and so forth and so on and whatever, okay? So by bringing the weave in, we can weave between two lists using a pattern. So if I plug the pattern in 0 and 1, and just remember when you use a panel that if you put in multiple lines, you need to right-click them and select multi-line data, because that way it thinks of it as a list. You then get a flat list with 22 objects, which I can then loft together. I can set the options of that loft to a straight loft, and I therefore get the beginnings of a stair. Okay? So what's one issue that we have with our stair? Let me just hide that and just show that. What's one issue with our stair? They're a bit angled, right? Okay, so let's do some analysis, okay? What height does what height does this need to be? Is there anything that we can extract from the model? Speak up, man. There's 40 people in here and I want them to hear you.
The next.
No. Oh, speak up.
The next point.
The next point, as in the height distance between this point and that point? That one? Yeah? Let's get it. Okay? So, what is our first line?
0.
Right. In a list index, our first line is always going to be 0. And what is our second line going to be?
1.
1. Okay. So, one way of doing this is we can add the little +1 to the list index. Everyone's familiar with this one? Yep. Okay. So that gives us the first item and the second item, yeah? So instead of measuring the actual line, let's get its point. So we'll pick a point on the line. So all of these lines, we will evaluate their length at 0 to get their starting point. We will plug that into our list item, and now we're using the points, yeah? And what factor of the point do we care about? If we deconstruct a point, we only really care about its z coordinate, right? Its height, yeah? So we'll get the z coordinate of the first point, the z coordinate of the second point. We will subtract them. Now, is there a chance that the start of my stair that is at the top? Is there a potential? So what that means is if I subtract these, y minus x, I could actually end up with a negative number, which I am, okay? So one way to force that not to be negative is if we put in the expression ABS, that forces all numbers to be positive. So if they're positive, they're positive. If they're negative, they're positive. ABS, absolute. So after doing that, that forces that to be positive, and we can then use this number to drive the Z value for our stair, okay? So we then get a nice little uniform stair. So now I can start playing with the length of the stair, the width of the stair with this surface, and the script will correspond to that like so. Cool? Okay, we've used weave to create a stair. Okay, pretty simple. Excellent. One other way of doing it is, so that's using weave. Weave and dispatch work really well, I believe, for trusses. And a lot of you are working on films that you have film inspirations that are quite industrial, and exposing trusses are a really good way of making something feel a bit more raw and technical, when normally, like, there are probably trusses above us right now, and they're just covered up with timber, right? We could expose them and actually make the building a bit more complicated. Like, they're definitely probably, see those, see these sort of like wing-shaped beams? They're probably a truss, and they're just covered up with aluminium. Okay? So what we can do is if we take two curves, we can produce a truss from them. Wow, it's only 5:38. I'm killing it. Hey, can one of you two grab my power pack in the mess that is my bag? It's not in the front pocket. It's not that one. Yeah, it's that one. No, not that one. Not that one. That one. Excellent. Thank you very much. Okay, so we've got two curves, and we want to divide them because we're going to use those divisions to create the truss points. Okay, everyone's familiar with trusses? No? Yes, good. Truss. You'll know what a truss is soon because I'll draw one. Can you swap that out for me?
It's Jonathan's.
Yeah, and someone else's now. Okay. So what we can do is we can take two curves. So we will bring a curve in from Rhino. Note, guys, a lot of the time I like to set geometry out in Rhino, like setting points out or setting lines and surfaces, because it's easy to work with. It's more intuitive. You can snap things and you can make sure that they work with other people's designs or work with a site model or like the actual context or something. So there should be no snobbery when someone opens a Rhino file up and it's only done in Grasshopper. Like you haven't won a prize or anything like that. Like it's okay working with the two environments, okay? The worst thing to do though is to bake something and then rebring it back into your script. Don't do that, okay? So we're gonna reference one curve and we will reference another. So these two curves are now in Grasshopper. We then divide the curves. So we now have two lists of points, and what I'm going to do is effectively create a list pattern that will create this type of zigzag along that, therefore then creates a truss, okay? So if I think about it, on the top, is there a way to recognize the types of points that I'm choosing to use? What is that way? What type of points have I chosen? Yep, so let's say the even points, yeah? And then on the bottom line, what points have I used? The odd points, yeah? So what we can do is we can dispatch our points using a pattern. So we can say, we're going to create a pattern where 1 is going to be even. So what is 0? Is 0 even or odd? It's even. 0 is even, okay? So 0 is always first. So 0 will be even. Therefore, the first one is true. And then odd will be 0. So we will then plug that into the dispatch, which means 1 is corresponding with A. So all of our even points are going to come out of A, and all of our odd points will come out of B, right? So now, if I pick out all of our even points from the first line and all the odd points from the second, we're good, right? We need to get them back into a single list again because we're going to create a polyline, just like I did with the stair. So we need weave. So we're going to use the exact same pattern of 0 and 1, 1 and 0. So that means 1s are going to come first. The A's go into 1, and our 0s that are odd go second. So they go into 0. And that then allows us to create a polyline. Where am I? I've lost myself. There I am. A polyline through there that then creates that zigzag. Yeah? Cool. So that means we can effectively control our truss using a slider. 2 is less than 20. So I can increase the number of divisions. Whoop. I can create brace flanges across that. So from each division to each division, I can create those vertical lines. And my truss line doesn't necessarily have to be straight. We can create arcs. And the system will follow that particular pattern that we've defined, okay? So this doesn't have to be lines. It has to be solid, right? Because we build things out of solid things, not thin, infinitely thin lines that can't exist in reality. So one really shitty way to do it, but it's good for beginners, is using pipe. So pipe is this guy. So if you plug that into a pipe, it thickens it up. It gives your elements weight and thickness, and you probably want to set the radii of these to be different. So the tops and bottoms are thick, and the diagonals are a bit thinner. So we end up with.
What does A stand for?
Pardon?
A in the pipe.
E.
Edges?
That's the end, so you can set it to flat or round or something like that. But there you go. That's a nice little truss that we could actually then line up and set up in our design to support the roof and bring some detail into the design. I know some of you aren't doing designs that would use exposed trusses. The point being that the dispatch weave requirement of the checklist is about you guys recognizing some patterns that you can achieve in your design and using dispatch and weave to create those patterns. So these are kind of the easy ways out, the stairs and the truss. So you can do way more with dispatch than just this, but this is just getting you guys to think about that, okay? I'm okay seeing stairs and trusses, that's cool. And this is kind of me giving you one of the checks, okay? So are we good? Excellent. Now, I've covered bringing geometry back into Grasshopper because some people sort of forgot about that. One other thing, if we bake stuff into Rhino, so I've selected a layer, I'm selecting my stuff, I'm baking, and now if I go into the Rhino environment, these elements can actually have materials applied to them in Rhino, and you can use Rhino Render to create images. And Rhino 6's render engine is actually pretty good, okay? These two were probably would have loved to have access to this back when they were doing this course. So actually, you were expected to use Unreal, weren't you? Huh? So what we can do is just in the properties in Rhino, if you select an object, you can see there is a tab called Material. If you select that, this guy's falling asleep. I'm going to draw a penis.
Oh, yeah.
Okay, so after selecting the object, you can select the Material tab in Properties, and here it's saying, okay, use the layer material. So you can define materials by layer, but you can also just put materials on objects. So after selecting that drop down, you can then choose to either use a new material or a default one. So let's make a new one. I'm going to make it plastic. And what we'll do is we'll just set this to rendered view. Now Rhino 6 is really nice. The rendered view is actually rather attractive. It puts a ground plane in, and it actually gives you ambient occlusion. And so how did I rotate it? I used 3D rotate. It is, if you right click rotate, you then define an axis, and then you type the rotation in and it rotates. Cool. So I'll select these guys. We're gonna work on the plastic material. we'll make plastic red.
Have a nice salmon.
And you can see that's then applied that, and it's even, see how it's glossy? So there's actually, you can play with the reflectivity of the materials, the transparency, and I'm pretty sure if you export this after you apply materials in Rhino to, if my program's like 3ds Max, then the material comes with it. I'm not sure if you're using Lumion if it will come over, but it doesn't hurt to try. It will? There you go. That's why we've got Branko. Yep. So you probably don't even need to use Lumion if you've got the Rhino 6 render, because there is actually, oops, not Grasshopper. They actually have, if you open up this little tab here, if you right click and you select the environments tab, environments, right? You can actually load other default environments in. So right now this is using a studio, but I could actually go import from the environment library and pick out, let's try, is there anything that looks like a park, Walden Pond, huh? No. We're in a garden. So let's choose the pond. Let's see what that does for us. Okay, we just have to wait for it to download. What? You didn't know about this? Huh? Yeah, I know. This is Rhino 6. So if I double click Walden Pond, so that's now given us like the Walden Pond environment. And you can see that's like the reflections and stuff are playing off that, right? You're getting a rather nice output. If I go, yeah, that's because it's low quality. But guys, just remember under display, in the display tab, you can turn off surface edges, and it's probably set to default for you. And you can also turn off the ground plane. So like it's not necessarily casting a shadow on the ground if you want, or like you can bring that into Photoshop. View capture to file, or will let you save the image that's on the screen. Cool, and then you can pull that into Photoshop. I believe this doesn't let you get alpha, but if you go to the render tools and just hit render, it will actually create a higher res image of that. This is just a really quick shotgun of Rhino render, okay? We're gonna do a bit more, I'm gonna talk a bit more about producing sexy plans and sections further down the line, okay? Just really quickly so you know, if you want to section something in Rhino, just type clipping plane. Then select vertical. Then you can draw a vertical plane through the object, and that'll cut it as a section. Okay? If your objects are solid, so if I just select all my objects and I cap them, then they'll come in with like a face. And if you select your clipping plane, this is a real crash course in how to use Rhino for images. If you go to display options, then go to the rendered view or whatever view you're using. Then I believe, under clipping plane objects, if you set the use planes color, and it said for color show fills, you can set that to solid color and then set that to black or white or whatever. In this case, we're going to set that to almost black. And that will then give you a nice like thick black edge. And you can even set the edging to black. Display options, clipping plane. So we can set that to solid color and make that, you know, almost black as well. And so you can see there, we're getting like a fairly reasonable section through that object. Okay? We'll get into that more as we start working on the residence. Okay? I'm not expecting you guys to give me really perfect plan sections and renders for this assignment. This is kind of like testing the water for you guys. You know, doing something with a bit of risk without actually me teaching you how to do it. Because I haven't had enough time to teach you. 3 weeks is nothing. Yeah? Okay? Thanks. I'll see you next week.